Thanks for that introduction, Patrick. Is my mic on? Okay, great. Let's see if I have better luck with this clicker than Todd did. Sorry, Todd. Okay, awesome. So, hi everyone. My name is Nolan Lawson. I am a program manager on the performance team for the web platform team for Microsoft Edge. This is the last talk of the day, so I guess normally I would make some kind of lighthearted joke about how I'm standing between you guys and beer, but actually I don't think I'm standing between you guys and beer, because I was just upstairs. There's actually kind of a big pile starting up. So I mean, if you're upstairs and you want to crack one open, like that, I give you my blessing. That is fine by me. If you want to bring me one, that'd be great. I don't have a glass of water, so that might be nice. So my talk is called Web Performance in the Real World: How to Make Fast Websites. And I want to start out this talk by kind of asking this really basic question about what is performance exactly, right? This question gets asked a lot, and the term gets bandied around quite a bit. What exactly does this mean? Well, you might think it's kind of a dumb question. Like, you might naively respond, what is performance? Oh, it's simple. It's just, we want to make everything fast, right? It's just make websites fast. But as it turns out, it's more than just got to go fast, right? Like, there's a lot of meaning kind of stuffed inside of that word, performance, right? There's lots of different kinds of performance, different dimensions of performance. There's things like page load time, PLT. This is asking the kind of classic question of like, okay, I've got a website. I type in a URL, I press enter. How long until I get some content on my screen, right? And this, for a long time, was kind of the most standard metric of how, quote unquote, fast a website was. But there's more than just PLT, right? There's things like animation performance, frame rate, right? You might have a nice button, say, on your social media site, where you can heart something, and you want your heart to, fill up with a nice little pink filling or something. And if you are dropping frames in that animation, right, it's going to appear janky. It's going to appear not quite so nice. Whereas if you have a lot more frames, then it might look much, much smoother, much nicer. This isn't really a question of fast versus slow, because the animation might take the same amount of time to run, but if you drop frames in one case, it will look bad, right? So that's another dimension of performance. There's also responsiveness, right? Have you ever had this experience where you had this nice web page and you wanted to click on this link and you clicked on it and you felt like stuff should be happening, but it kind of wasn't happening, and instead your cursor just kind of became this little hourglass or maybe the beach ball on Mac, right? And that's because the web page is not responding to your input very well, right? Like the amount of time between the input you are giving to the browser in the form of a click or a touch or whatever, and the output is really high. So that's another dimension of performance, right? So to answer the question, what is performance? Well, it's really all of the above, right? It's things like PLT. It's things like animation, frame rate, smooth versus janky. Responsiveness, right? How fast does the browser respond to my input? Plus many, many more definitions of fast that you can think of. So now that we've kind of gotten that definition out of the way, when we think of performance, we think of all of these things and more. The other thing I want to kind of mention at the beginning of this talk is I work on the performance team for a browser, right? Whereas most of you out in the audience, I imagine, work building websites as opposed to browsers, right? And you might be on the performance team for a website even. But I think it's kind of interesting because there's kind of a fundamental difference in perspective between those working on performance in a browser vendor and those working on performance for a website. Like, we're both kind of attacking the same problem, but we've got two different perspectives on it. So I kind of wanted to draw that out here. And the way I might describe this difference in perspective, if I were to put it into a short little pithy quote, would be something like, web developers want to avoid anti-patterns, right? You want to avoid the stuff that you might be doing to make your website slow. Whereas browser developers want to take those same anti-patterns and just make them faster. Right? So what do I mean by that? Well, another way to put it is this. Like, the way I see it is that you out there building websites, I would say your view of the world is something like this, right? Like, you have this nice website. It's got a call to action. It's got nice branding and all this stuff. And you're saying to yourself, OK, I want to make this website run fast in all these different browsers. So I want to avoid any anti-patterns that are going to make it slow in one browser or multiple browsers. So that's your job, right? That's your perspective. And on the other hand, this is our perspective. So we've got this browser, and now we need to take it and we need to make it fast on all these different websites. Okay? And I did not illustrate all of the possible websites out there because it turns out there are approximately 3 gazillion websites out on the internet, and our browser needs to be fast in all of them. So, I mean, I'm not trying to say that our job is harder than your guys' job, but our job is harder than your guys' job. like a lot. And also, we are looking out in the web, and we are seeing lots of anti-patterns. I mean, you guys want to go out there and get rid of those anti-patterns in your page, and that is a noble goal, and I wish that every single web developer shared that goal and they were consistent about implementing it, but the reality is that there's a lot of code out there on the web, and a lot of it is not very nice. And yet we still have this browser to build, we have users to please, and we have to make our browser run fast for all those websites. So here's an example of the kind of anti-pattern that we see really, really prevalent on the web. This is a simplification of a piece of code that I actually saw on a real website on their homepage. I'm not going to call them out because I don't want to shame anybody, but this is kind of simplified, but this is basically what the site was doing. If you look at this and try to think about what's wrong with this code, well, let's figure out why this might be slow, right? So we've got this function, it's taking an element, right? And we're writing to the DOM, okay? We're setting the height on the element to 0. And then immediately afterwards, we are reading from the DOM. We are asking for the bounding client rect, right? The rectangle for the element, it's x, y, it's left, right, it's width, height, all that stuff. And then just for kicks, we are going to do that in tight loop 5,000 times, which means this is a layout thrashing party, right? I've simplified this, but this is basically what the website was doing. Actually, it was a bit worse than this even. But this is what we have to deal with out there on the web. And I mean, if you're a web developer, you're looking at this and you're thinking, okay, I want to go optimize and get rid of this. But if you're a browser vendor, you see this stuff every day. It's brutal out there. So like, we looked at this and we were like, okay, well, let's think about this. Like, why are we even layout thrashing, right? Like, the height is not even changing, right? Like, it's just being set to 0 over and over and over again. Like, why are we recalculating layout over and over again? It turned out, actually, that we just had a bug in our engine, essentially, where we should have optimized such that we didn't need to recalculate layout, but because the site was setting layout to the integer 0, and then we were comparing that to the transformed height, which was now the string 0px, like, that was where the bug came from. And it led to a huge performance problem in Edge HTML. So we actually fixed this in Edge 16. And for this contrived little demo that I came up with, it's way, way faster. So we've gone from like 300 milliseconds to less than 50 milliseconds. I think on the site, on the actual site that this occurred on, it was even more drastic. It was somewhere in the neighborhood of like a second. So finding these anti-patterns and making them faster can be a huge win for the browser. So in short, like, what my goal is as someone on the performance team for the browser is I want to take these browser performance experts, these people looking for these anti-patterns that we can speed up, and I want to find the web perf advocates, like those people out there who are trying to find these anti-patterns and eliminate them from their websites, and I want to bring these two people together. And we do this in a program that we call Performance Club. And a Performance Club is very, very simple. Yeah, I chose the most flattering picture of myself, I know. Performance Club, in essence, is very, very simple. We just basically take the performance team for Microsoft Edge, we take the front-end team building some website, and we just get them together in a room and have a meeting. And we try to identify the parts of the site that could be sped up, and we work to make the browser faster and the website faster. We spend a lot of time looking at tools like this. This is Windows Performance Analyzer, which is actually the tool that Windows developers use to make Windows faster. This is what we sit down and use to analyze a website, and we share this knowledge with people in these performance clubs. You don't have to try and squint to understand what's going on in here. I mean, when I show this to most people the first time, their reaction is just kind of like, there's all these colors and graphs and charts and numbers. But one of the services we provide in perf clubs is that we are the people who make the browser. We use this tool every day, so we can kind of look at this and figure out, like, oh, here's layout thrashing. Oh, here's get bounding client rect. So essentially, the output of a performance club is we identify these slow pieces of code, right? And we give this to the browser developers so they can try to make it faster. And then also give it to the site devs so they can go and try to eliminate it from their pages, or at least eliminate the most egregious one, or maybe use a different pattern, something along those lines. And this Perf Club program has been very successful. I've been doing this for the past year or so. It's been about 60% of the time, I would say, that I spend on my job. And so it's been very, very successful. We've met with many, many partners throughout the past year. I've met with many teams inside of Microsoft, outside of Microsoft, probably 24 or so. You might have noticed that on this slide, I've gone over it with my black CIA highlighting pen. And the reason I've done that is because I cannot tell you which teams that we met with in the past year. This is actually not something that we share publicly. We don't talk about these perf clubs publicly. We don't share the results from that. And the reason for that is that, as it turns out, the first rule of perf club is you do not talk about perf club. And the reason for that is that it should be obvious if you just kind of think about it for a bit. Imagine yourself in this performance club meeting, identifying these anti-patterns, and let's say that you're in a perf club, and let's say that you found a perf problem. All right, so you found something on this website that is slow, that could be improved, some dumb mistake that someone made or something along those lines. So there's one of two possible outcomes here, right, if you were to go and talk about this publicly. The first outcome is you make the website look bad compared to their competitors, right? Because you're going out there, and if you're going and talking about it on Twitter, essentially you're airing their dirty laundry, right? You're pointing out some bad mistake they made that is slowing down their website. You're making them look bad, right? And this is not a good way to get repeat customers, people that you want to come back and do a performance club with you again. So that's one possible outcome, right? Another possible outcome is you found something where maybe they've coded things in a particular way where one browser has the optimization and the other one doesn't. Well, in that case, congratulations, you have made your browser look bad compared to some other competitor browser who doesn't need to be named. So either way, it's a bad situation, right? So this is not something that we do in perf clubs. We don't go out and air people's dirty laundry. We don't put people on blast on Twitter. We don't publish the results of these perf clubs. As I like to call it, perf clubs are a no-shame zone. Like, you can come into perf clubs, and what happens in perf clubs stays in perf clubs, and we're not going to go out there and shame you in front of the general public. So that's all I got. So we can end the conference about 20 minutes early, because all the perf clubs are private, so I can't share any of this information with you. So you guys, you get to go to beer faster. I'm sure you're happy about that. I'm just kidding. So there's going to be something that I can bring to you, right? These are private. We don't share the nitty-gritty details of what goes on in performance clubs, but there must be some learnings I can bring to you from meeting with all these different teams over the past year or so. And in fact, there are. The first piece of advice that I would give you from having met with about 24 teams over the past year and identifying their performance issues, the first one is that there is no magic performance dust that I can give you to just sprinkle over your websites. There's no one single solution to making websites faster. As it turns out, every site is kind of a special snowflake. They're all unique, right? Like, we look at 5 different sites, and we find 5 different ways that they are slow. And then we look at the 6th slide, and we're like, wow, I didn't even know a site could be slow for that reason. Right? Like, we find new ways that a site can be slow every single day. So every site is unique, and you have to kind of understand the special shape of your site. The other thing I would say is that a lot of people kind of do this thing where they try to memorize all these performance tricks. Just go through a book of like 1,000 performance tricks to amuse and amaze your friends, and I'm going to go from top to bottom. I'm just going to apply each of these things to my site, and it'll be fast. But it turns out, you can learn 1,000 different performance tricks, and then your site actually needs the 1,001st. Right? So I would say is, more than anything, what you should do is not so much learn about performance so much as learn how to learn about performance, right? It's okay to learn the 1,000 tips and tricks, but you should learn how to then extrapolate from that to figure out the 1,001st. So in that vein, what I'm going to do in this talk is I'm going to cover 3 basic topics to hopefully give you an idea of how you can start to look at your website's performance and start to think of solutions to problems you may see there. The first thing I'm going to talk about is marks and measures. Then I'm going to cover scrolling performance. And then I'm going to finish with intersection observer. OK, so first off, marks and measures. This is a really, really cool standard W3C standard API where you can set a start and an endpoint using JavaScript and then measure the time spent between those two. And what's really great about this API, I think, is that it lets you kind of define your own language for how you want to talk about performance in your website. So think of it this way. You remember that slide I showed about, these charts and graphs, it's confusing. I think that's how most of us feel when we open a browser's performance tools, right? So this is the Edge performance tools in F12. This is the Chrome DevTools. It can be bewildering when you first look at this. And the reason for that is because this is the browser telling you in its language how it views the performance of your website. But what the performance mark and measure API allows you to do is it allows you to insert into those DevTools your own custom performance marker. So you can name things. You can name, if it's the call to action button I'm clicking on, you can call it call to action. Right? And when you do that, you will actually see it show up alongside in the browser's tools. You will see your way of thinking about your site's performance lined up with the way the browser thinks about performance. So it's a really, really useful API. And it's extremely easy to use. All you got to do is call performance.mark, to set a mark for the start, and then you set a mark for the end, and that will measure whatever thing you're trying to measure. It doesn't have to be synchronous. You can do this asynchronously as well. And then you call measure to measure the total time spent to do that operation. And then at that point, what you get is you get this whole what's called a performance timeline, where it's essentially like a whole history of all the operations you might have done on this site over time. And you can take that whole object and send it off to telemetry or whatever you want. This API is supported in Chrome, Edge, IE, and Firefox, by the way. And if you find this a little bit too verbose right here, what I'm showing you, there's actually a little wrapper library I wrote called Marky that can do the same thing in a lot less code. This is the exact same thing as the previous slide, but with much less code. So you can check this out. It's on NPM if you want it. Fun fact about this library, the only reason I named it Marky is because I really enjoy typing marky.mark. So if typing marky.mark is something you enjoy as well, maybe this is the library for you. So that's marks and measures. The second thing I want to cover, switching gears a little bit, is to talk about scrolling performance. And the reason I want to cover this is because this is one of those subjects that I think is good for someone working for a browser vendor to bring out to web developers because it's kind of counterintuitive or maybe even surprising to a lot of web developers. And the essential insight I want to give you here is that the web is multi-threaded. It might be comfortable if especially if you're used to working mostly in JavaScript, or if you come from Node.js or something like that, to think of everything as being kind of single-threaded, right? And that is true to an extent, right? So there is this thing called the main thread, and that is where JavaScript work is queued. And it turns out that's also where things like style calculation, layout calculation is queued. But browsers have worked very, very hard to optimize scrolling, because scrolling is a very fundamental interaction to the web, to make it such that scrolling can be done on a background thread, independent of all this stuff going on the main thread, which is often a traffic jam because everything's trying to run on the main thread. But unfortunately, there are certain things you can do in JavaScript to disable this superpower of the browser to move scrolling to a background thread. One of those things, it turns out, is adding a wheel listener. So in this example, I'm adding a wheel listener to the document. And the reason that this will disable independent scrolling is because you've got this callback in here, right? And you've got this event. And you can call event.preventDefault on that. And what that means is you'll block scrolling. Now, even if you have event.preventDefault behind some if statement, or even if you never call it at all, the browser isn't sure if you're ever going to call event.preventDefault because JavaScript is dynamic, right? So the browser looks at this and thinks, OK, you've added this wheel listener. You might block scrolling. So I need to go run some JavaScript when we scroll to figure out whether I'm going to block scrolling or not. So what that does is that takes this nice situation where we've got JavaScript, style, layout, all in the main thread, and then scrolling on a separate thread, and it makes the scrolling thread go, wait a minute, I actually got to go back to the main thread, I got to go back to the traffic jam, right? And I got to go queue my JavaScript to run. And even if your JavaScript callback is really small, you got to wait in line. You got to wait for layout to finish, style to finish, any other JavaScript operations that might be queued up, you got to wait for those to finish too. And then at the end of all this ceremony, then your scroll handler can run, and it might even determine, hey, I actually don't need to call prevent default. But at this point, you've already blocked scrolling. So there are a few solutions to this problem. One simple solution is that instead of adding this wheel event to the main document, you can just add it to a subscroller. So say you have a page where you've got the main section is scrollable, and then there's a subsection that's scrollable, and you're only interested in scroll events for that subsection. Just add the wheel listener to the subsection. Don't add it to the whole thing. Because browsers have optimizations where they can make sure that the main page remains free to scroll up and down, even if the inner one is blocked. Yeah. Don't block the whole document if you can avoid it. Another thing you can do, this is kind of counterintuitive, but the scroll event, as opposed to the wheel event, actually doesn't block. And the reason it doesn't block is this, is because there's actually no event that you could pass in for the scroll event where you can call event.preventDefault. And because you can't call event.preventDefault, this actually doesn't block scrolling. So you can use the scroll event instead of the wheel event if it gives you the same effect that you want. The thing to keep in mind, there's really only 3 events you need to watch out for that can block scrolling. There's wheel, which I already mentioned. Then there's also touch start and touch move. So really just be very suspicious of these events. When you see these events in your code, scroll is fine. But wheel, touch start, and touch move, be suspicious of those ones. The other thing you can do, this is a thing that just recently is starting to ship in browsers. We ship this in, we are shipping this in Edge HTML 16. It's also supported in Firefox and Chrome. And what this is passive event listeners. And essentially what you do here is you add this object that says passive true on this wheel listener. And with this, what you're saying to the browser is, OK, browser, I pinky swear I will never call prevent default on this event. And because you're doing that, the browser doesn't have to go back to the main thread, doesn't have to go back to the traffic jam and figure out whether that's ever going to happen, because you promised it that you won't. In fact, if you call it, it's just a no-op. OK, so all of this is very interesting and theoretical, and but at the same time, you might be looking at this and saying, OK, no, like that's all interesting, but I have a big pile of code that I call my website, and I just want to know, have I blocked scrolling somewhere? Is there something I've done that you've talked about that has blocked scrolling? And it turns out there's a very easy way to determine this. I've written a very small JavaScript library that you can use to determine whether or not this is happening. And this JavaScript library is so small, I don't even need to publish it on NPM. I can just publish it on these slides right here. And I call this code the Jenkinator. And the Jenkinator is extremely simple. All you need for the Jenkinator is you do a little set interval, like to run, say, every 5 seconds. And then inside of that code, you're going to grab the current time with date.now. And then what I want you to do is I want you to just have a nice little while loop that just kind of spins and spins and spins for as long as you want. Here I'm doing it for 4 seconds. So essentially what this code will do, if you drop it onto your page, is every 5 seconds it will just block the main thread for 4 seconds. And you can just open up the DevTools and just paste this in, and you will immediately see if you are blocking scrolling somehow. So here's an example. I've got this page where I'm doing this, and as you can see, I'm trying to scroll, and nothing's happening. Oh, then I can scroll again. Oh, but then it's blocked. So if you just drop the Jenkinator into your page, just open up the DevTools, paste it in, you will find out immediately if you're blocking scrolling. Now, the truth is, this gets a little complicated because it turns out there's many, many flavors of scrolling, and they are in various stages of being optimized by various browsers. So there's like wheel scrolling, there's two-finger touch scrolling, single touch scrolling on a touch screen, clicking and dragging the sidebar, pressing page up, page down, up arrow, up, down. So you might have to test a few. But if you want to know the nitty-gritty details of all this stuff, I have a blog post where I explain how all of this stuff works. And it's got some nice animations from Rachel Neighbors on it, too, to act as the sugar to the bitter pill of all this complication of how scrolling actually works. And you can check this out later. OK, so the last thing I want to cover is Intersection Observer. And the reason I want to cover this is this is a new API that is just starting to ship in browsers. We shipped it in Edge HTML 15, as well as an update in Edge HTML 16. And bringing it back to the concept of looking at your page and trying to understand the performance aspects of your page and then applying a solution to that, one of the things that came up frequently in performance clubs is we would see something like this. Like someone would have a page where they had some kind of scrolling, like say a virtual scrolling list. And we look at it and say, there's a lot of time being spent in get bounding client rect, right? And or scroll top, client height, client width. What's going on here? Well, essentially what they had was they had this scroll element. OK, they had this scroll element, right? Something you can scroll up and down. And then they had some elements inside of that. And what they're doing is they had this scroll listener, right, that was checking the get bounding client rect, so checking the rectangle, right, of this inner element, and then comparing that to the scroll top. And they're doing that on scroll. And the thing is, even if you've optimized your scroll handler using all the stuff I just talked about, the problem here is that you are still forcing layout by calling these two things, right? So as you're scrolling, you're just forcing layout by calling get bounding client rect. Right? And as it turns out, there is a new API you can use to just get rid of all of these costs. And that is Intersection Observer. And the way that this API works is that basically it's a way of you telling the browser, OK, hey, browser, I've got these two elements right here. Right? I got this outer thing and this inner thing. And what I want is I'm going to register a callback. And you tell me when this inner thing intersects the outer thing. Right? So it's more of a push-based than a pull-based method. Instead of constantly pinging the DOM and saying, hey, what's the relationship between these two? The browser tells you when the relationship changes. And it's really, really easy to use. This is a little quick demo I whipped up where you can see what's happening. I'm just changing the class on some elements as they scroll into view. And you can see I get this callback that gives me a wealth of information about the relationship between the inner thing and the outer thing. Right? I get the rectangle for one. I get the rectangle for the other. I get whether or not it's intersecting, what the intersection ratio is, the time that it happened. I get the element itself. You get everything you could possibly need in here. And the code is extremely simple. Like, to use Intersection Observer, all you need is you grab your outer element, you grab your inner element, and then you instantiate a new Intersection Observer object. You pass in your callback. you designate which element is the outer one and which one is the inner one, and you call .observe on the inner. And then what's going to happen is inside of your callback, you're going to get this list of entries. And this is going to tell you, these entries are going to, you're going to receive them every time the relationship between those two elements changes, and you're going to get all that information that I just showed you. So there's many, many things I love about this API, but just a few things quickly that I love about it in particular. First off, there we go. First off, if you want, the outer div can actually just be the whole viewport. If you just want to know when something comes into view or out of view, you can do that. You can also observe on multiple objects inside of, by using the .observe method, so that's really, really convenient. And then also, most crucially, these recs, these rectangles you get here, are free. Like, these don't trigger layout, right? You're not calling get bounding client rect. You're not forcing the browser to recalculate layout. You just get this for free. And this is supported in Edge. Firefox just shipped it in Firefox 55. Chrome has it, and then there's a polyfill you can use as well. OK, so I mean, this is just an extremely useful API. You can use it for lots of different scenarios, but just a quick list of things you can use this for. You can use it for things like virtual lists, like I explained. You can use it for ads. This is kind of the classic case for Intersection Observer. You want to know when the ad was on screen and how much of it was visible and how long it was visible for. You can also use it for things like ellipsis effects, like if you want like some nice little truncation effect where when an element gets to a certain size, you show a nice little tasteful ... or something like that. Basically, you can use Intersection Observer for any situation where you have a box on top of another box and you want to know when the relationship between those two things changes. So it's extremely useful. OK, so wrapping this up, I've covered 3 major ideas to kind of illustrate how you might think about performance, how you might think about analyzing your website and applying the right solution to it. So the first one is marks and measures, right? Defining your own vocabulary for the performance of your website, and then laying that on top of the information that the browser is giving you. Scrolling performance, understanding that the web is fundamentally multi-threaded, and trying to avoid those things where you could be blocking that thread. And then Intersection Observer, just this enormously useful API for working with 2 boxes and how they might be interacting with each other. So I want to leave you with a few thoughts on performance to kind of wrap it all up. First off, as I said before, performance is more than just fast. Right? There's many, many different dimensions of this. There's frame rate, there's responsiveness. All of these things are different dimensions of performance. And then learning 1,000 tips is not really enough. I mean, I kind of just gave you 3 more tips. But you can learn these 1,000 tips to really learn how to learn about that 1,001st that you might need for your website. Right? Learn how to do the investigative process. And part of that investigative process is to be measuring. Just always be measuring, right? But use the Performance Mark and Measure API to define what's important to your website. Make sure you're keeping track of that so you know when you regress or not. And then this is just, I mean, really not, it's never said enough. Just test on slow machines, honestly. Like, you will learn so much about performance by just buying some cheap laptop or cheap phone and looking at how your site looks on there. Like, that is really the best instructor when it comes to performance. And then also, this one isn't said enough either. Just test iteratively. Like, just make sure that you're continually testing performance. You're testing on slow machines as you build your website. Because when you're building a website, it's kind of like you're building this Jenga tower, and then once you put enough blocks on there, you realize that it's unstable, but you don't quite know like which block it was that made it so unstable. But if you test as you build it, then you'll know exactly what you did to make it so slow. So for instance, instead of saying, oh my gosh, we just did 1,000 commits and I don't know which one slowed down the website, but something did. If you're testing as you commit, you can say to yourself, oh, it was that last commit that slowed us down, and I can tell because I'm constantly testing performance. And then if you want to do a performance club with the Microsoft Edge team, you can get in touch with us. We have this alias, so you can just email us at perfclub@microsoft.com. We also have a Perf Club bar upstairs if you want to meet us there, and we can do an ad hoc performance club with you there. So that's all I got. Thank you very much for listening, and hope you had a good conference.